Okay, second installment, ladies and gentlemen. The last video that I posted dealt with the length of an arc. Okay, so for Wednesday and Thursday, you guys are going to be asked to try and practice these questions on the two documents posted on Google Classroom. All right, they're both titled, Week 5 Circles, Arc Length, and Area of a Sector. You'll see them on Google Classroom. They're the PDFs. It'll say Wednesday and Thursday on them. Now, what I want to do is just pick up right where we left off, all right? So I'm going to get into this example in a second, but I just want to remind you of a few main ideas. 45 degrees in this first example is the central angle, okay? Let's remember that the arc measure, all right, the number of degrees out here is equal to that. But that's arc measure. That's number of degrees. What we're focused on today is going to be not only the length of an arc, but also the area of this sector, this slice of pizza. So you're going to hear me refer to the length of an arc as the length of the crust on the pizza, right? If you notice here, I've highlighted in pink, that length is the outside curved distance, not degrees. In this case, it'll be inches or miles or meters or whatever. Okay, we're going to use 45 degrees and the radius to find that length. It's going to be a portion, like we said, of the total circumference. Now, here's the cool thing about it. In our last video, we said that part of the degrees is to all of the degrees, as part of the circumference is to all of it, right? Or more simply, I'm going to use this formula. Theta is to 360, as arc length is to all of the circumference, okay? The good thing about this new idea is the formula looks almost identical. Okay, because think about it. We're basically going to take a fraction or portion of the total area. But here's the big difference. Instead of using circumference for the area of a sector, all right, if I want to find this yellow shaded region, I'm not going to take a fraction of the circumference. That doesn't make sense. We're going to take a fraction of the total area. So one more time here, guys, take a look. Now, you'll hear me go through just a couple quick examples, but the area of a sector, I just wrote here, it's the space for the cheese and the sauce. All right, the arc length is the length of the crust. Area of the sector is all the space inside for the cheese and the sauce. Okay, so again, last time, theta is to 360, part is to whole, as part is to whole. So we're going to say sector area is the part of the area, pi r squared is the total area. Let's dive in. All right, example number 1, I'm going to work through with you completely, and then I'm going to give you some hints for the rest of the two documents. So here we go. Find the arc length, which I have in pink to match the crust, and the area of the sector, all this shaded space here in yellow. If the central angle is 45 degrees and its radius is 4 inches, it says to draw a sketch below and show your work. Now listen, I didn't measure this, I just took a guess. As you can see in number 2, you're going to try to draw your own. Okay, but I figured, you know what, I know 40, if I went straight up, that's 90 degrees. But if I make it shorter, more of like an acute angle, I'm going to assume that's 45 degrees. All right, here we go. I'm going to remind you guys every single time you do this, just like when we were back in school together, write your formulas. So I have arc length. Part is to whole as part is to whole. Remember, I have to make sure that I use part of the circumference for arc length. Later on, I'm going to use the full area for area of a sector. So here we go. Theta is to 360, so I'm going to start with that. That's 45 is to 360 as arc length. Do I know arc length? Oh, no, we're trying to find that. So I'm going to leave that as the variable L. Pi diameter, pi d is the formula for circumference. So what's the diameter? Well, the radius is 4, diameter will be 8. So ladies and gentlemen, I have 45 is to 360 as arc length is to 8 pi. You can simplify this fraction. I usually like to. If you have your graphing calculators, I'm just typing off to the side now, but I could do 45 over 360, math, enter, enter. Okay? Believe it or not, 45 out of 360 is 1/8. So basically, this is 1/8 of the circle. So I'm going to simplify that. You don't have to. You could leave it as is, but now I'm going to cross multiply. I'm going to get 8L equals 8 pi. I'm going to divide both sides by 8, and the arc length, ladies and gentlemen, is 1 pi, or just pi inches. Okay, pretty straightforward. Just substitute your values into the formula and cross multiply. All right, now, I'm going to move on to the next one now. Now, you've got to be careful. I've seen a lot of mistakes from years to years. This is pi diameter. That's part of the circumference is to all of the circumference. Now, if I want just the shaded region, I have to use part of the area, the sector area. That's a sector. And I'm going to compare it to the total area, not circumference. Now, guys, I've already done 45 to 360. So I'm just going to skip that step and write 1/8 already because I'm still talking about 1/8 of the circle. However, you're going to notice a difference over here. Instead of arc length, L, I'm going to use S for sector. But now I'm going to have pi radius squared. What is the radius? 4. 4 squared is 16. The total area of the entire circle is 16 pi. So basically, we're trying to take 1/8 of it. I'm going to cross multiply and get 8S equals 16 pi, right? And then I'm going to now divide both sides by 8. 16 pi divided by 8, that gives me 2 pi inches squared. Okay, I'm leaving these both in exact form, alrighty, but if you wanted to, you could type that in a calculator and get the approximate. All right, guys, listen, it's really that much the same, all right, where the formulas look very, very similar. The only difference is going to be L to full circumference, S to full area. Now, you're going to try numbers 2 and 3, but I've started to set up number 4. I want you to notice something. Take a look. It's the same directions, except look what changed, though. They're telling us that the measure of the arc is 300 degrees. Guys, that's most of the circle, okay? So I drew this myself. So I knew if I went halfway around, that's 180. If I went another 90 degrees, that's 270. So I just threw it over here, right? Now, technically, this is 60 degrees here left over, but we're not using that. We're trying to find most of the circle. So I'm going to start you off here, guys, but I want to let you finish, okay? So for arc length, again, I'm going to write my formula. My theta, my central angle, is 300 degrees. So I'm going to write 300 is to 360 as arc length is to pi d. Now, I got to be careful here. Guys, be careful. Look, diameter is 8. I'm just trying to draw some attention to this. The diameter is 8, so actually, once again, excuse me, our radius is 4, and in this case, it's meters. Okay, so I'm going to go ahead and write down my arc length, my circumference is pi d. That's going to be 8 pi. So now when I go calculate my arc length, I'm actually going to simplify this, right? So I'm going to have 300 over 360. Math, enter, enter. And this simplifies nicely, right? Actually, that was pretty simple itself, right? It would be 30 over 36, which is 5/6. Okay. So ladies and gentlemen, I have my proportion. You guys can finish that on your own. I'm going to skip over to here. Theta over 360. That's 5/6. I just calculated that. I'm going to copy that over here. It's the same proportion, the same amount. However, big difference. Big difference again. Remember, area of the sector, part of the area is to all of the area. Pi radius squared. That's 16 pi. Okay, guys? So that should get you going. I just wanted to explain the formula for the area of a sector. So in this first document, you're just going to keep practicing. You're going to keep practicing. All right, I'm going to post the solutions to these on Friday with your check-in. You don't have to technically hand this in. This is for you to practice. All right, so on the second document, you'll notice the second one is called arc length and area of and sector area, and it's got the little Olympic symbol up top. Okay. So what I wanted you to notice here, and I'm picking example 2 for a very good reason. Sometimes you'll be given information that has pi, sometimes you won't. So the directions here say find the approximate radius of a circle with the given circumference. So they're giving us circumference. So that's the C in each of these, okay? Show your formulas in solving calculations. So if I'm supposed to find the radius, but they gave me circumference, I'm writing the circumference formula, all right? And then I'm going to substitute that 102 right here. So now as I write this, I'm going to have 102 pi equals pi d. Now, in my opinion, guys, this is a little easier when I have the pi's on each side, right? Because I could just go ahead and divide those out, right? So now to finish this up, I'm going to have 102 equals d, diameter. So we have to be careful. That's not my final answer. They want the radius. So if I want the radius, but I know the diameter is 102 centimeters, I'm going to divide that by 2 and get 51 centimeters and label my units. Okay? Now there's a big difference here. When I have the pi, you saw what happens. When we don't, please notice that you're going to get an approximate answer, an infinite decimal, and you're going to have to round. Whereas this one was equal and exact, this one is going to be approximate. Okay? So I'm going to have 18.4 equals pi d. Now, be careful here. What do? I'm trying to get the diameter alone. So I actually want to show my calculator for this one. I'm going to divide both sides by pi, just like I did in the previous example, but look, the pi's cancel out here on the right. There isn't a pi up top in the numerator to cancel out here. So I'm going to take 18.4 and divide it by pi. Try to use that pi button. It's more accurate. And I'm going to get approximately 5.856. All right, so I'm going to say diameter is about 5.86. But again, be careful. They wanted us to find the radius. I'm just going to click divided by 2, and I'm getting about 2.93, and that's going to be feet, as you can see. Okay, now last thing I'm going to cover here in this second video, and it's going to kind of piggyback off of this. Later on, you're going to be asked to, deal with arc length and area of a sector, but they're going to give you some different information. So here we go. All right, in this example, they tell us that the circle has an arc length. So guys, they're starting off by giving us the arc length. They're telling us the arc length is 4 pi feet, all right? And then its diameter is 12 feet. All right, so actually, hold on a second here. I'm going to put 6 feet under each of these, right? Because each radius is 6 feet, total is 12. Now it says use this information to find the values below. Find the exact measure of the central angle, theta. Be sure to use your formula. All right, so listen, hold on a second. I'm going to stop right here. Since they're giving me arc length, I'm going to write the arc length formula. If they gave me area of a sector, I would write that formula. But here we go. I want you to notice a little bit of a difference here, okay? As you can see, we're trying to find the angle, find theta. So I don't know it. I'm leaving it as theta is to 360, as arc length is to circumference. But wait a second. I have arc length. So they're actually giving us L this time, right? Maybe I'll just put L above it. That's the arc length. So that's 4 pi over pi diameter. My diameter is 12. So my circumference is 12 pi. I just talked about this, guys. Isn't it nice when we can just divide out the pi's? So I'm going to simplify this and get theta is to 360 the same way 4 is to 12. Wait a second, guys. What is 4/12? 4/12 is 1/3, right? So basically we're talking about 1/3 of this circle, but I'm still going to cross multiply. I want to show you what I mean. 3 times theta, maybe I'll come up here. 3 times theta is 3 theta, all right? And 360 times 1 is 360. If I divide both sides by 3, I get 120 what? Feet? No, degrees, okay? Remember, we were trying to find the central angle. Now it also says you can label all the information on the diagram at the right as you go. So I know that this is 120 degrees. So here's what I'm going to do. I'm just going to make this an obtuse angle. I'm going to make this 120, okay? And then that means that this arc length out here was 4 pi. Okay? In the next step, it says use your angle from part A to find the area of this sector. So you're going to be finding the area of that sector. Okay, just before we move on, I'm going to make sure we write theta is to 360 as what? Area of a sector. So I'm going to make sure we have S is 2 pi r squared. Okay? And the last thing I'm going to say to you is this. It's just a couple more practice questions, the same idea. All right? But for accelerated students, there are 3 extra questions on the back here. I'm going to post a separate video after this to help you with that one. All right? It's optional for academic if you guys want to take a look. So, in summary, all right, there are 3 videos for these couple days. In this section, we are talking about arc length and area of a sector. You should keep using these formulas. I hope that helps, guys. Good luck.